Hello, everyone, and welcome to this breakout session. My name is Ber Javakian. I am product owner of BricsCAD Mechanical, and I'm joining you from Munich. In this session, we will present how BricsCAD Mechanical is helping to shape the future of 3D assembly design and the integration with downstream processes. I will elaborate on common challenges seen around 4 main design workflow steps. Those steps are adding parts to an existing design, edit and constrain, maintain a smart parametric assembly, create quick design documentation, and finally, create insightful visualization assets. I'll share with you BricsCAD's approach to handle those challenges. You will see brief demos that our team have prepared for this session using data from a solar tracking panel project. With rapidly changing markets and shorter product life cycles, product designers and makers are under constant pressure to deliver on short tool cycle times and budgets. Hence, many of our customers find it critical to use efficient CAD systems that can give them all the features they need while keeping away unwanted complexities. When we are developing a new product concept, it is very convenient to start our idea from another existing 3D model or a comparable shape, either for inspiration or for comparing best options. We can download and import loads of CAD models from online catalogs, then just use those as a basis for the work. Many classical CAD systems often miss the agility needed to fully handle non-native imported data. They are best in handling native formats but limited towards foreign or exchange formats. It might be surprising that companies report missing design due dates for failing to fully reuse their own existing CAD models. That can be due to conflicting CAD formats or errors made following complex multi-CAD workflows. As a result, engineers may be obliged to redo some design work. In large projects, there is a collaboration with other designers, suppliers, and partners. Each party takes over designing specific units of a complex product. In the extreme example of designing vehicles, up to 80% of the parts could be designed and fabricated by different suppliers. By any cost, all the CAD data must perfectly fit together. So in similar work scenarios, we will have a huge advantage if our CAD system can handle any second-party components, integrate them directly to our assembly. Here, practice shows that partner data often have some issues or miss critical details by the time they are needed. Engaging in email communication may lead into long ping-pong exchanges and becomes a burden for the design progress. So it is smarter to unbox such data, edit and reshape them to be able to pinpoint the exact issues and requirements. This facilitates communication and reduces costly errors. Having described this challenge, let's see how BricsCAD can give our team the comfort to leverage any existing CAD data, regardless of its source and maturity. In our scenario, the CAD team has finished most of the design work, but to finalize it, we have one more thing to do. An actuator must be integrated into the system to drive the tilting mechanism. Those parts are typically provided by tech suppliers, so we will simply import the CAD file we have received from them as step exchange format thanks to our importing capabilities of BricsCAD Communicator. After reviewing its correctness separately, we can then insert it to the main assembly and roughly place it in the 3D space. Let's tilt the frame and add a few necessary concentric constraints. We need one between the faces and one for the rotation axis. Note that those axes are always fully identifiable even though the 3D data is not native. As we can see, the actuator is too small for this assembly. It is not a blocker. We can change that from here. Let's start by dragging the stroke to where it should be and constrain it to the upper mounting hole. We now see the gap clearly. So let's modify the stroke and extend its length until it reaches the main cylinder. We are not extracting profiles or creating new sketches. Just select and drag. As the stroke is now longer, the cylinder should get longer with the same extent. Let's repeat the same procedure. Select the contour and directly drag it to extend the extrusion. We should finally pull the gear component along the cylinder to the very end. At this point, the resizing work is finished. The imported actuator becomes usable on our assembly. As you see, in BricsCAD, we can choose how to start our design work. If it's from scratch or from any existing CAD data, it's all up to our resources, timeline, and project goal. With Communicator for BricsCAD, we can seamlessly import geometry from all major CAD applications. We can challenge the status quo through direct modeling. Any CAD data will be easily repurposed to fit the new needs. We start with a base, then detail it by adding, removing, and deforming geometry as we need. Note here that BricsCAD also maintains design intent throughout this process by automatically recognizing equal dimensions and geometrical relations between surfaces. To know more about the design intent recognition, please visit our BricsCAD Help Center page for design intent recognition. Once having a completed design that initially fit the requirements, it's very tempting for the design team to call it finished. In reality, those designs will have to undergo several changes early and even quite late during the product cycle. By planning in advance, good product teams can create smart, changeable models that behave in predictable ways when modified. It is achieved by parameterizing the design. In contrast, non-parametric designs lack the agility to changes. If a part is to be changed, the rest of the model will not adapt correctly. An unconstrained assembly would behave as a group of parts combined together without sufficient definition of how they should mechanically interact with one another. That will also not allow checking product kinematics to tackle related issues. Let's go back to our demo and see how we can easily work with parameters and constraints within the assembly context in BricsCAD. Let's make the design one bit smarter by defining a transition range for the moving stroke. To do this, it is best to open its 3D mechanical block in New tab. Let's define the relative distance between the stroke and the cylinder and set that as a new parameter. By default, this distance is not restricted to any range. In our case, we should set the upper and lower bounds so the stroke never leaves the cylinder. Let's check that. Here we go. It's a good practice to rename this parameter for a better readability, for example, to better distinguish it later among other parameters within the main assembly. As all the necessary constraints are added, we can easily play the animation to review the resulting kinematics. The tilting mechanism here functions within the defined ranges. No collision is identified. To optimize the tilting performance and improve the structural safety factor, we will add a second actuator. My favorite way is to copy-paste, so let's duplicate the first actuator we have just prepared in the step before. As a mechanical block, the actuator maintains the constraint between the subcomponents. Let's add 3 more constraints so our assembly is fully defined. On the axis, once again, and 1 more for the faces. Here we go. The integration of the actuators is complete. We can play the kinematics to see the new results. BricsCAD provides a simple and rich toolset to maintain smart models that allow users to control 3D geometric models with rules and parameters. It can help to efficiently define all necessary assembly constraints and run kinematic animations for an excellent visual reviewal. A good practice is to define critical design parameters and dimensions early in the design process. In BricsCAD, parameters can be linked together across the assembly via simple and advanced mathematical expressions, all accessible in a simple UI. Smart models allow generating multiple possible design variations to analyze and compare, then choose the best for the requirements. After finishing the actual design work, the engineers won't rest yet. They will spend additional hours on tedious 2D design documentations that guide fabrication, procurement, and service. This is estimated to be between 20 to 60 of the total engineering time. Those efforts are still largely manual in most workflows. Sometimes they get too much on the way that they distract the team from the core design work. As each resource in the team may have a different experience and understanding of the standards, it becomes challenging to constantly generate the needed documentation in a similar fashion that everyone will understand. Non-standardized documents may lead to misinterpretations and many requests for clarifications from the downstream processes like procurement or manufacturing engineers. But documents are not just created, they are also continuously updated. Once a feedback is received after manufacturability review, new details are added and CAD models are changed accordingly. Classically, those changes are corrected manually on all existing documents. Some companies report delays by frequently receiving faulty or outdated fabrication docs in shop floor. This increases their scrap rate and decreases the on-time delivery. BricsCAD Mechanical is handling those challenges intelligently, thanks to the smart algorithms. Let's go to our demo example and see how we can generate correct bomb exploded views automatically in drawings with just a few clicks. So let's have a closer look at the slewing drive. This assembly contains several subparts such as a housing, flanges, shaft, different bearings, and the bolt. Perhaps a quick section view from the 3D working area will reveal the complexity better. With a high density of parts, creating exploded views manually in a useful order might be a time-consuming and an error-prone task. But in BricsCAD, that all can be generated automatically. Let's activate the setup for the automatic explode feature and execute it. Here we go. We generated our exploded view instantly. To review the disassembly process, we can now play the exploded animation after setting the step duration we want. It is defined in milliseconds. Let's play the animation and review it. Notice that the collisions are avoided. Also, we see one group coming off at a time. This is good to give the step-by-step clarity we want. It gets even clearer with the trailing lines. Those trailing lines are available in both manual and automatic explode modes. Let's create a drawing and add an exploded view to it. Click through the drawing view options to define the scale, size, and ratio. From the BOM manager, let's insert a BOM table. We can also include a cell for the sum number to read the total number of parts in our assembly. Pin the table to the upper right corner. To conclude this drawing, we will enrich the exploded view with the numbered balloons. With one click, we will create a link between the exploded geometry and the corresponding BOM table. Note that those smart balloons and their support lines do not cross or overlap. This is very convenient for readability. We have seen how accurate bomb, drawing, and assembly explode animations are made with as little actions as possible. With the accelerated automatic explode mode, the algorithm in BricsCAD finds the best disassembly sequence of components with respect to the assembly hierarchy. It can also give anyone instant insights about design for assembly, manufacturability, and serviceability. The explode avoids possible physical collisions and identifies the ideal direction of movement of each part. Automatically created design documentation will reduce error and enhance clarity in downstream processes. By improving documentation processes, engineers are less upset and more focused on solving design problems and making valuable analysis. If the new design can deliver a high value, that's great, but if it's not presentable, we will soon have a hard time convincing people. Product visualization is critical for product success. Visualization assets accompany our products throughout their entire life cycle, whether to drive sales, avoid expensive prototypes, create training materials, or even interact with our products. One fundamental way to leverage the power of visualization is during the making of early product decisions. Studies show that over 80% of the product development costs are related to stakeholders' early choices. Without the right design presentation assets available in the right time, companies will be challenged to bring key stakeholders on board to create the common understanding, address issues, and adopt good plans. VR, AR, game engines, and metaverses are all mind-blowing technologies that have brought unimagined new ways to virtually experience new products and services. However, it's no-brainer that they come with exploding complexity and costs, raising concerns about their returns of investment. To use those technologies, we would also require file exports and data preparation. Once leaving the CAD environment, the CAD data will lose most of its parametric definition and assembly relations. Then new updates on the original CAD design may not propagate to the animated model. Outsourcing to specialized agency is a flexible alternative here, but often worth considering for marketing and sales projects where the high-end visual results really matter. Yet experience shows that agency briefings are often misinterpreted due to different understanding of product functionalities and communication barriers. In general, sharing unreleased product data externally imposes IP protection and confidentiality concerns. In the end, there are no guarantees where the data might end up after sharing it. In BricsCAD, we think if we can design a product, we should be able to clearly tell how it can solve a real-world problem. We put the right number of tools at the tip of users' fingers to help get this job done. Let's go back to our demo project and see how simply we can render accurate animations. We can see the scene is already in place. We want to animate additional physical conditions, for example, the sunlight. Let's go ahead and turn it on. Add a date and time. Then select the required geographic location. Here we will choose the gorgeous city of Ghent where Bricsys headquarters is located. Also, let's enable the physical shadows to demonstrate how our system can autonomously rotate and tilt to face the sun and capture as much as possible of the sun's energy. Now we will do the timeline. It starts with setting the total duration for the camera to record. Then add the sun to the timeline. With the new release, we can fast play the physical sun transition by specifying the starting and ending times. It works by modifying the sun's azimuth and altitude. Despite the simplicity on this example, BricsCAD can handle complex scenarios including creative camera movements. Once we are ready, we can hit Render to open the dialog window. Here, we can select the required resolution and quality, then choose among different common video file formats such as MP4, AVI, and WMV. Now let's give BricsCAD a moment to execute the rendering and come back. We can use the video as it is in a presentation or enrich it with text and annotations as necessary in a video editing application. In a world full of technological changes, relying on visual representations has become more relevant even for mechanical products. In BricsCAD, we can easily create accurate parametric animations from any design parameters. With our new release, we added the capacity to animate the sun's altitude and azimuth. By working in our CAD environment, we will leverage the exact parametric CAD definition and product correct kinematics. With simple tools built inside BricsCAD, any user can independently highlight his design's features. Creating images and videos will not necessarily require additional file exports and third-party tools. By adding lights, shadows, and props and other predefined behaviors, a level of realism and wider context is included to our design presentation materials. Note that in the next BricsCAD update, we will be able to render the same accurate parametric animations, but in a full ray trace visual quality to boost the visual impact right from within BricsCAD. Our today's session comes to an end here. In this session, we had a glance at how BricsCAD helps you to start with any CAD data you want to give you the head start over your competition. You can optimize your design, smarten, and repurpose any models with the power of variational modeling. By using simple-to-use assembly commands, you can assemble and animate your products for kinematic review in record time. With BricsCAD, you get time-consuming manual steps automated by smart algorithms, as in the intelligent explode view. Lastly, with BricsCAD, telling product story means simplicity and accuracy. With just a few clicks, you will create video materials of your product in action from any parametric animations. If this session was interesting, please make sure to watch our other breakout sessions for BricsCAD V23 release. Thank you for your time and stay safe.